Another way to explain this, very, very graphically. Sir, can you help me out? Fish. Thank you. Can you stand up here? What's your name? Mike. Mike, okay. Good. You look cool. We are crystals. We are occupying the same pixel, and we can swim anywhere we want. Yeah, okay. Now, we're German fish. Now, what happens when you electrify these crystals? I need somebody to go zap. Zap.
Uh-oh. Hey! Last night it took the guy like 5 minutes to figure that out.
Now we're in the white level position because light shining behind our pixel can go through. Now we want to make black level. Ready? Black level, go.
First shot. Mike, that's cool.
Middle shade of gray. 5 degrees. Let's get brighter, brighter, bright white. Go to black. Flash white. Flash white. Little gray. Excellent. Thank you. Please come and see us in my office in the back. See the Epson projector in the JVC.
Question?
Hold on. Any questions?
Yeah, one
You're not going
question for
anywhere.
you, Jeff.
Yeah.
We won't let you out that easy, but one of the issues with LCD in comparison to some of the other formats is a convergence issue. And could you explain how the convergence is done and why it is an issue?
Not in this period of time, I can't.
Oh, you can't.
He's asking a very, very good question and a very technical question. And there's the light engine here. I can just point out
here's the
something.
light engine.
Yeah. Hi there.
Like he just
Can I see the light engine
with the fish?
Can you show it to me?
Explain it with the fish for us.
Or I can do this with the prism. You guys have the prism light engine?
Yeah.
Wait, Jeff, you don't want that back, do you?
Actually, I'll leave it with you. I'll serious. You can have it. Yeah. Have we got the lead crystal prism?
Here you go.
Okay.
Oh, you're famous now, Alessandro.
Okay, good, thank you. And I need one more of the bigger SD things, SD chips. Is that out there? Oh, no, I got it. So what my knowledgeable friend is referring to is the actual position of how the LCD, remember 3 LCD, all LCD projectors have 3 chips. What he's actually referring to is the actual position that these chips are glued, and we super glue them to the lead crystal prism using the finest Japanese super glue. We use Gojira glue. So what he's referring to, and he's got tremendous visual literacy. He's not normal. I mean, he can see the feathers on an eagle at a mile away. And what he's asking about is he wants to know, he wants to absolutely, to his vision standards, with his face up against the screen, he wants these things to be absolutely...
No, 11 feet away, not face up against the screen, Jeff.
When was the last time you were within a foot of the screen?
When was the last time? When I was checking out a machine.
Today?
No, but I did check it from 11 feet back, Jeff, too.
So what he's referring to is the actual position that the LCD chips are super glued on the prism.
It's panel alignment is what you're talking about.
The panel alignment, yeah. And at Epson, we do our best to get every projector within 1 pixel alignment on that. That is our standard.
That's good.
Great question. Thank you. Anybody else? Okay, I think
Hey,
I've
Jeff, can you
used
talk
my...
about how when you crop down to 235 or 240 or 185, do you use all the pixels?
No.
You crop the LCD as well?
You do, yeah.
I thought you use all the pixels.
We are a big fan at Epson of anamorphic. We're a fan of the anamorphic system. Now, all these projectors and displays are 16:9 native. There's only 3 aspect ratios out there. There's the almost square of standard definition. There's 16:9, which is the HD or sports, high definition format. And then there's 235, which is the aspect ratio of Hollywood. 70% of all Hollywood movies are in this wider 235, 240 aspect ratio. 90% of the top 100 blockbuster movies in the history of Hollywood are in the 235, 240. I mean, there's Raiders, Harry Potter, Jaws, I mean, it just goes on and on. So if you are a Hollywood movie buff, and I'm talking seriously addicted like myself, I'll watch 3 or 4 rented movies in a weekend. I want my movies to be 30% wider. That's the difference in 235. They're 30% wider than 16:9. When you see black bars top and bottom on a 16:9 display, those black bars at the top and bottom are very, very bad because they are pixels that are not being used. They're shut off. And in a 1080p display, which is 2 million pixels, the black bars top and bottom represent about 660,000 pixels that are dark on you. So when you use an anamorphic lens with a projector, you do 2 things. You light up all of those pixels and the image improves in 2 ways. It gets brighter by about 20% and the perceived detail, the amount of information is the same, but because more pixels are being lit up, the perceived information to your eye is much greater. So brighter and greater perceived detail, I mean, this is video meth to a Hollywood movie person. It really is.
So you do it right.
We do it right.
Okay.
We absolutely do it right.
You don't lose the pixels.
You don't lose
You
them.
reformat them to the new format, to the
That
new
is-
aspect ratio.
That is correct.
And that's not every projector does that.
Not every projector. Some projectors have what they call zoom memory stops and blocking to kind of simulate it. You lose part of the picture, but it doesn't light up all the picture, all of the pixels. It doesn't give you the benefits.
So that's a
of-
positive.
That's a positive.
Yeah.
But you need an outboard anamorphic lens
You
with,
do.
with specific processing to achieve that.
Right.
Correct. And we have the processing in our projector. We do partner with Panamorph, which we think has the same mind space that we do, in that is we try to be a tremendous value for the dollar. We partner with Panamorph and we think they do a good job with their lens. And that's available through Epson as a Panamorph lens.
Beautiful. Thank you.
Okay, thank you.